So hi students, now we will discuss one of the another topic in the digital electronics, which is positive logic and negative logic. So here positive logic means we will apply 0 voltage for 0 volt logic 0 and plus 5 volts for logic 1. So we can say like this in another way, logic 1 is applied higher voltage compared to logic 0. Okay, higher voltage is given for logic 1 and lower voltage is given for logic 0, then it is positive logic. Negative logic means higher voltage is given to logic 0 and lower voltage is given to logic 1. So for example, in this logic 0 is given plus 5 volts and logic 1 is given 0 volts. So in the examination, sometimes in the previous examination, this question is asked. In ECL, in inverter coupled logic, logic 0 is given minus 1.7 volt and logic 1 is given minus 0.85 volts. So if we compare these two, higher voltage is given to logic 1. So if higher voltage is given to logic 1 and it is positive logic, the question is what type of logic for the given question. And let us solve one more question. So logic 0 is given minus 5 volts and logic 1 is given 0 volts. What type of logic is it? Is it positive or negative logic? The question. Now here let us compare the voltages applied. If we compare the voltages, the logic 1 is given higher voltage compared to logic 0. So the answer is, the given question is of positive logic. And this is a very simple question, but in sometimes you have given some truth table and all, you need to write which type of logic and what type of gate also. And for understanding that, let us consider AND gate. Let us consider the truth table of AND gate. We already know the truth table of AND gate. Let us write A, B, and Y. Right? There should be some gap between A and B because we have to write some voltages also in addition to the logic levels A, B, and Y. The truth table for AND gate is 0, 0, 0, and 0, 0, sorry, 0, 1, it is 0, 1, 0, again it is 0, and 1, 1, 1. So, in addition to this, the logic levels, you will do like this. For 0, 0 voltage, and for 0, 0 voltage, wherever there is 0, 0 voltage. And for 1, they have applied 5 volts. Like this, the question is asked like this. It is given in the question. And similarly here, 5 volts, 5 volts, and 5 volts. The question is, you may ask like this: what type of logic it is? What type of logic it is? The options are like this: positive logic AND gate, negative logic AND gate, or positive logic OR gate and negative logic OR gate. Those are the given possible options. Now here, we came to know that higher voltage is given to logic 1 and lower voltage is given to logic 0, and this is similar to the truth table of AND gate 111, 100, and 010, 000. So the answer for this is positive logic AND gate. Suppose in the options, if there is no this question, this answer positive logic AND gate, sometimes there may be some other possible answer, that is negative logic AND gate, negative logic OR gate. These two are equivalent. The positive logic AND gate is equivalent to negative logic OR gate. Okay, this is very important. In the options directly it is not given, AND gate is not given, but only OR gate, the OR gate options are there: positive logic, negative logic, or none, something. Now then you have to choose this option. the negative logic OR gate. So the positive logic AND gate is equivalent to negative logic OR gate. So how we are getting this? By using the property of dual. Now, sometimes for this question, for the same truth table, you are asked to write what is its negative logic. Let us assume that the given question is some positive logic, and you are asked to write the negative logic. So how do you write the negative logic? Using the property of dual. Dual means wherever there is AND, we need to convert it to OR. Wherever there is OR, we need to convert it to AND. And again, 1 to 0 and 0 to 1. So here there is 0 is present. Let us convert to 1. We should not change any voltage levels, only logic 0 to 1. 1, 1, 1. 1. So here 1 is there. It is converted to 0 and 1. Next 0, 1, 1, 0, 0, 0. And we should not change any voltage levels. 5 volts like this. I am not changing any voltages, only I am changing logic 1 to 0 and 0 to 1. Then if you observe in this, if you are observing this, logic 0 is applied higher voltages. Logic 0 is applied higher voltages, and this is called as negative logic OR gate. Negative logic OR gate. Higher voltage is applied to logic 0 and lower voltage is applied to logic 1. So the summary for this topic is positive logic AND gate is equal to negative logic OR gate, and similarly negative logic AND gate is equal to positive logic OR gate. So sometimes the truth tables are also not given. The questions may like the questions they have given some circuits like this, using some diodes and resistors like this. It is output Y, and here you need to apply VCC. So for this circuit, this is generally it is an AND gate. We are asked to what type of gate it is. With respect to logic level, also we have to mention. So for this question, if we apply positive level, if we apply positive level, positive logic, if we apply positive logic voltages, the circuit is acting as a AND gate. But if we are using the negative logic voltage levels, the same circuit can be used as an OR gate. Okay, the given circuit is AND gate. For this circuit, if we apply positive logic voltage levels means for 1 5 volts and for 0 0 volts, then the entire circuit is acting as a AND gate, positive logic AND gate. For the same circuit, if we apply negative logic voltage levels means for 0 5 volts and for 1 0 volts. If you are using negative voltage logic levels for this given circuit, you will get the truth table which is similar to the truth table of OR gate. Then the same circuit can be used as positive logic AND gate and negative logic OR gate. Similarly, you may get the question like this. This is also one more question, and generally this is the OR gate. Here it is an OR gate. For this OR gate, if we apply positive logic voltage levels, it will act as a positive logic OR gate. And if you apply negative logic voltage levels, the same circuit can be act as a negative logic level and gate. So I hope you understand this video. If you like this video, subscribe our channel. Thank you.